So here's a question that's honestly pretty troubling. Why would a common form of breast cancer see basically zero improvement in survival rates for more than 30 years? It's a huge question, and today we're going to unpack a paper that offers up a pretty radical new answer.
Okay, so what is this central mystery all about? Look, we've made these incredible, mind-blowing strides in treating so many cancers, right? But then there's this one specific type. It's called diffuse invasive lobular carcinoma, or ILC for short, and it's just been stubbornly resistant to, well, everything. That word diffuse is key. It means it spreads out, kind of like a web, instead of forming a neat, solid lump. And for 3 decades, all our best efforts haven't moved the needle on patient outcomes, not one bit. So the big question is, why?
And this graph? Wow. It really shows you the problem in black and white, or, well, red and blue. The blue line, that's survival for cases diagnosed between 1996 and 2010. The red line is for cases from 2011 to 2022. And they're pretty much identical. They're right on top of each other. Think about that. Despite all the medical advancements we've had in that time, this survival curve has basically flatlined. It hasn't budged. This data right here is our starting point. It's screaming that we've been missing something really fundamental.
All right, so to figure out what we might be getting so wrong, we have to go back. We need to look at what's been the accepted wisdom for over 75 years. The textbook theory of where this cancer even starts.
So the story kicks off way back in 1941. You have these 2 researchers, Foote and Stewart, and they put forward an idea. They propose that ILC starts in what are called epithelial cells. Those are the cells that line the milk-producing parts of the breast, the lobules. But here's the kicker, and this is so important. They openly admitted they didn't actually have the evidence to prove it. It was just a hypothesis, an educated guess. And yet somehow this unproven idea got picked up, it got popularized, and it became the established fact that's been repeated in medical textbooks ever since.
But what happens when you actually look closely at the cancer itself? Well, that's when the old theory really starts to unravel. It just falls apart. There are all these clues that they don't add up, and they all seem to be pointing in a completely different direction.
Okay, clue number 1. This cancer doesn't grow in a nice, tidy lump. Like we said, it spreads out in this weird web-like pattern, which is super unusual for a cancer that's supposed to come from epithelial cells. Clue number 2, it's missing a really important protein called ecahedrin. Now, you can think of ecahedrin as the glue that holds epithelial cells together. The textbooks have always said the cancer cells lose this glue. But what if they never had it in the first place? And finally, clue number 3, our standard treatments, the ones specifically designed for epithelial cancers, they just don't work that well here. It's like we've been trying to open a door with a totally wrong key.
So if the old theory is just full of holes, what's the alternative? Well, this is where the paper we're looking at proposes something really radical. A complete rethink. A completely new origin story for this cancer.
The new theory suggests this cancer doesn't come from those epithelial cells at all. No, instead, it originates from something called mesenchymal stem cells. These are basically the structural connective tissue cells of the breast. And suddenly, all those weird clues we talked about, they just make perfect sense. These mesenchymal cells naturally don't have that ecahedrin protein, so there's no mysterious loss we need to explain. And because they are connective tissue, it perfectly explains why the cancer spreads out in that diffuse web-like way. It's like all the puzzle pieces finally just click into place.
So because of all this, the researchers are proposing a brand new name, breast cancer of mesenchymal origin, or BCMO. And look, this is way more than just a name change. It's not just semantics. It's a critical red flag for doctors, telling them, hey, you are dealing with a fundamentally different disease here. It behaves differently, and it needs to be treated differently.
But wait, the investigation goes even deeper. This is where it gets really fascinating. The researchers discovered that the thing we've been lumping together and calling classic ILC, well, it isn't one disease at all. It's actually 2 totally different cancers. And they've just been hiding under the same name this whole time.
And you can see the difference with your own eyes right here. On the left, that's the dangerous one, the extralobular type. See how it just spreads out in that ghostly, web-like pattern? Then on the right, you've got the intralobular type. It forms a much more contained, spiky-looking mass. I mean, visually, they're just worlds apart. This table breaks it down even more clearly. They start in different parts of the breast connective tissue, they grow in completely different ways, they look totally different on a mammogram, and, this is the most important part, they have vastly different prognoses. One is pretty manageable, and the other is extremely dangerous. So what does this actually mean for patients in the long run? Well, take a look at this survival graph. The two lines, they start out together, but then, over time, this massive gap, this chasm opens up between them. That gap right there, that's the difference between life and death, and it's been hidden in plain sight for decades, all because we were calling two different diseases the same thing.
Let's put some hard numbers on those curves. After 19 years, the survival rate for the manageable, intralobular type is 84%. Pretty good. But for the dangerous, extralobular type, it's only 56%. That is a staggering 28 percentage point gap. These are so clearly not the same disease, and they absolutely do not have the same outcome.
Okay, so this discovery, it changes everything. It absolutely forces us to completely rethink how we diagnose and fight this cancer, because it reveals that the tools we're currently using can be dangerously misleading.
Let me walk you through a tragic but real-world scenario that the paper describes. So a patient comes in, and she has the dangerous extralobular BCMO. Her molecular tests, which, remember, are designed for epithelial cancers, come back and they actually predict a favorable outcome. But her mammogram, the imaging, clearly shows a pattern that predicts a poor outcome. So you have this huge conflict. And in that situation, the molecular data can give this false sense of security, which can lead to undertreatment and, ultimately, a fatal outcome.
And that brings us to what might be the most critical takeaway for doctors and patients right now. For this specific cancer, what we see on the image is more important than what the molecular tests are saying. The patterns on a mammogram, the imaging biomarkers, are a much more reliable predictor of how a patient is going to do in the long run.
So this all comes together in one powerful idea, and it's summed up perfectly by the authors themselves. They say that by appreciating this cancer's mesenchymal stem cell origin, we open up a radically new approach to research and treatment. It's a total paradigm shift, and it's one that could, finally, allow us to develop treatments that actually work, and maybe, just maybe, start to bend that flat line on the survival graph that we saw at the very beginning.